the next topic that we're going to discuss is about the machine learning scale. So scale features. So when your data has a different values and even different measurement units, so it can be difficult to compare them. So what is kilograms compared to meter and altitude compared to time? So this different unit, so hindi siya pwedeng i-compare, na? Okay, basically lain sila nga unit. So the answer to this problem is scaling. We can scale the data into new values that is easier to compare. So take a look at the table. It is the same data set that we used in multiple regression. But this time, the volume column contains values in letters instead of cubic meter. So 1.0 instead of 1,000. So yes, we have car, model, volume, weight, and CO2. Okay. So it can be difficult to compare the volume 1.0 with the weight 790, but if we scale them both in comparable values, we can easily see how much the value is compared to the other. So there is a different method for scaling data. So in this lesson, we will use method called standardization. The standardization method uses this formula. So okay, we have this standardization method. When z is the new value, x is the original value, and u is the mean, and s is the standard deviation. If you take the weight column from the data set above, the first value is 790 and the scaled value will be, yes, 790, no? Ikuwaon nato ni siya, class. So the first, the u is, the x or the original value is 790, and ang iyang u is ang aton nga mean, no? And s is the standard deviation. So we can have this one. 790, we will be getting the standard, the mean, and the standard deviation. Okay, so we will have the standardized or scaled value. Okay, so if you take a column, a volume column from the data set above, the first value is 1.0, and the scaled value will be 1.0 minus 1.61, so that divided by 0.38, so the new value is negative 1.59. So can compare negative 2.1 with negative 1.59 instead of comparing 790 with 1.0. Okay, so we can have that one. This value is, of course, the this value for the weight, and ang 1.0 is for the volume. Okay, and after getting the standardized or scaled value for volume, so pwede na naton siya dayon. For weight, we can now compare it with the volume, no? And you do not have to do this manually. So with the Python, we have a scikit-learn module that has a method called standard scaler, which returns a scalar object with a method for transforming dataset. So scale all values in weight and volume columns. So for example, we just have to import Panda, scikit-learn, linear model. We have to import the standard scaler, okay, and the scale, is equal to standard scaler. So this is basically the syntax, so you have to remember this one. And we have to define, we have to get the column weight and volume, and then we apply the scaled x is equal to scale that fit underscore transform. So this method will transform the x, no? So, buot silingon, whatever we input here, kay ti, syempre, gin-assign naton nga ang aton x value, which is the independent variable, both these two. Makuha na naton dayon ang iyang scale fit, or scaled value. By just having this line of code, we don't have to perform this operation, like we have to get the mean and divide the standard deviation. So, kung gusto may manunuhon, pwede man. But, of course, we have this function already in the scikit-learn that scaled x is equals to scale.fit transform x. So, may ari na kita dayon, no? By running this one, may value na kita ya. Hindi na naton kinalan manumanuhon. So, that means to say this is for the first row, second row, third row, fourth row. Okay? So, this is for the volume. This is for the weight. Okay, so the result, note that the first two values are negative 2.1 and negative 1.59, which correspond to our calculations. So now we have to predict the CO2 values. The task in multiple regression lesson was to predict the CO2 emission from the car when you only knew its volume, its weight and volume. When the data set is scaled, you will have to use scale when you predict values. So kaina, because we have the actual or real data for weight and volume, so ginagamit lang kita sang multiple regression, and we predicted the CO2 using the actual weight and volume. But we can use the scaled value or scaled data to predict the values as well. Say, for example, so ato na siya nga ginkuha, no? Gin-scaled na naton siya. And then, of course, we apply the linear regression. So, linear regression, this is the function, no? And regression that fit scaled x and y. So, amo na ni siya ang aton nga kuhaon, because this represent the dependent, this represent the independent, which is already scaled. Okay? So, not yet, wala pa ning na scale, sorry. Ang ari lang anay, no. And then we have to scale the scaled the both of them, no. This value that is 2301.3. So we can now predict the scaled the CO2, I mean, by using the scaled value of volume and weight. Okay? So, amo na siya class ang kinalain, no? So, again, scaling is when we use or when we wanted to compare two different unit, no? Hindi naton siya ma-compare or hindi naton gid siya makumpara sa isa kag isa. It is because they are using different units, or basically ikaw ba naman i-compare mo ang kabug-aton kag ang volume, so hindi gid siya pwede. But using scaling, we can assign a value which is standard value, then pwede na naton siya dayon ma-compare. Okay? So, that's all for the ML scale.